Good afternoon or good morning, depending on where you are in the world, or maybe even good evening. Welcome to the webinar for the month of July. And we're going to be talking about a new certification as well as technical specification that the Wi-Fi Alliance has released this year. It's called Wi-Fi Aware as to the certification, and it's called NAN as to the technical specification. So we'll talk about the details of it in this webinar. It'll give you an overview of it, help you understand what it's all about. And then you'll know if you want to go and get more information on it. And maybe you'll know what you're seeing if you see some odd communications out there in the wild in the coming years as devices begin to adopt this. My name is Tom Carpenter. I'm the CTO at CWNP. And you can find me on Twitter at CarpenterTom. And of course, we are at CWNP on Twitter. If you want to tweet anything today, you can use the hashtag CWNPwebinar in your tweet to kind of get our attention, to let us know that you're talking about it. So we're going to be covering Wi-Fi Aware and NAN. So first we'll talk about what Wi-Fi Aware is, then we'll talk about what NAN is, because the reality is that Wi-Fi Aware certifies that a device implements NAN according to the technical specification. So we'll talk about the features of Wi-Fi Aware, what it provides, the technical architecture, and some use cases as we go throughout the presentation today. We'll go for roughly 30 minutes or so, and then if you have time to hang out and have some questions, we can deal with some questions. If not, of course, we'll understand that. This webinar, as all webinars are, will be archived on CWNP TV, which is our YouTube channel. So go to YouTube, search for CWNP TV. If you haven't subscribed, you can do so, and then you'll be notified automatically when new videos are posted, including webinars, other videos, as well as the weekly Wireless LAN News Desk. So first of all, some news from CWNP. CWAP and CWDP, the new versions content is well underway. We're building new study guides, courseware, practice tests, and exams, e-learning. We already have several chapters of the study guides done. We have the courseware almost completed for CWDP and well underway for CWAP. Practice tests are done for CWDP and for CWAP, and exams are in the editing process now as well. So everything is moving right along toward that September 1st launch date. So look for those announcements coming up in late August. September 1st will be the new versions of CWAP and CWDP as far as resources being available to begin your studying. And October 1st will be the first date that the new exams are available at Pearson VUE. Also, Wi-Fi Trek 2018 is getting closer for San Diego this year. We're about 86 days out at this point in time. And we do have a special running through midnight Sunday, so anytime through July 21st. And that is that if you register for the conference, you'll get a free e-learning coupon for a friend. You can register for the conference by putting the conference in your cart and then putting an e-learning program in your cart of your choice, and simply use the coupon code TREK18LEARN. That's TREK18LEARN, TREK18 LEARN. And that'll give you the e-learning for free. You'll also be given information that you can provide to your friend so they can get a free e-learning as well. So that's a special that's running through midnight Sunday. Don't miss Wi-Fi Trek this year. We've got a great lineup of speakers, and I'm very excited about what's developing there, in addition to a phenomenal lineup of trainers for the pre-conference training this year. Okay, so what we're here to talk about is Wi-Fi Aware and NAN. So what is Wi-Fi Aware? Well, it is a certification program of the Wi-Fi Alliance. The Wi-Fi Alliance has been in the certification business since the beginning, and they certify hardware/software to be compliant with their defined portions of the 802.11 standard. So for example, if something is Wi-Fi Alliance 802.11n certified, then it means that it's going to work with other 802.11n devices that are also certified by the Wi-Fi Alliance. And when they receive a certificate, it's more than just, okay, it supports the 802.11n or 802.11ac PHY. It also includes the security features they have, such as the EAP methods supported, and whether they're WPA2, eventually WPA3, and so on. So all of that is certification. But the Wi-Fi Alliance has kind of crossed over. So when I'm teaching CWNA now, we talk about the organizations that develop standards, the organizations that certify hardware, and the organizations that regulate how RF can be used. So you've got regulatory agencies like the FCC and ETSI. You've got standards bodies like IEEE, IETF, and so forth. But then the Wi-Fi Alliance used to be in that certification category alone. But now they kind of cross over between certification and standards development because they develop technical specifications as well. You can't really implement a Wi-Fi aware device with just purely 802.11 alone. So 802.11 doesn't have everything in it that Wi-Fi aware requires. In order to do it, you really kind of have a combination of 802.11 and NAN. So the two of them work together. And NAN is a technical specification, or what we generally call a standard in the industry, right? So very important to understand the Wi-Fi Alliance is kind of crossing over between those two now. Wi-Fi aware is contextually defined peer-to-peer group-based connectivity. So contextually defined. What that means is you're connecting for a particular reason, a particular service, and within a particular geographic location. So supported in Wi-Fi aware is ranging capability, for example. So you can indicate that, well, this application's only going to work if the two peers are within roughly 20 feet, 25 feet, 30 feet of each other, right? So there's a range that can be implemented there. It's group-based because more than one device is involved. I mean, technically you've got two, you've got a group, but it can be a cluster with far more than two involved in the communications. And actions, as I said, can be based on proximity. So what you do or do not do can be based on the range determined using actually a algorithm that is defined in the 802.11 standard. And we'll talk more about that later. Typical Wi-Fi connection ranges apply. So when you think about the range that an iPhone could talk to another iPhone in an ad hoc network, that's basically your range, right? So, or at least your maximum range without specifying some other range-based proximity. And it may operate concurrently with cellular connections or even with Wi-Fi. So in other words, you can be part of a Wi-Fi aware cluster or network and at the same time be part of a traditional 802.11 BSS. Now, how exactly the station handles that is not fully defined in the NAN specifications. It is something that is left for the designer, the developer of the device to figure out, but it is allowed for because there are time windows when the device can be communicating on Wi-Fi and time windows when it can be communicating on Wi-Fi aware. So, but keep in mind, they're all using the same physical layer. So the same rules for communications are going to apply to a Wi-Fi aware device that applies to a straight up 802.11 Wi-Fi device because they're all going to use the same contention algorithms. In other words, listening for RF energy above a certain signal threshold, listening for 802.11 frames above a certain signal threshold, and not communicating if they're there. So they're still going to use the same EDCA or DCF algorithms that are already defined in 802.11 down at those lower layers and even at the modified MAC layer. So Wi-Fi aware certifies the device implements a Wi-Fi aware network, which is a NAN network or a NAN cluster. So NAN is neighbor awareness networking. And as I said, this is a technical specification of the Wi-Fi Alliance. So NAN or neighbor awareness networking is the specification that Wi-Fi aware certifies. So as it's implemented in Wi-Fi aware, no access point is required. It's a peer-to-peer technology, a group clustering technology. There are several different components built into NAN, and we'll talk about them in a little more detail as we get into the architecture. But there's the NAN API. So this allows applications to talk to the NAN engine. So the NAN engine is comprised of the discovery engine, the data engine, the scheduler, and the NAN MAC, which is a modified 802.11 MAC layer. So all of this is part of that NAN engine. And the API allows an application like an iPhone app or a laptop application or what have you to talk to the NAN engine. All of these other components, the discovery, the data, the scheduler, the MAC, it allows it to talk to them. So there's a standard API that is defined for communications so that applications can take advantage of Wi-Fi aware. It still uses the 802.11 PHYs, either 11N or 11AC. And it is important to know that when you're talking about NAN or Wi-Fi aware, you've got networks and you've got clusters. So a NAN network is one or more NAN clusters that are typically non-overlapping. They may overlap in some of the geographic region with RF space overlapping, But the point is that devices communicate in a cluster, but that cluster may be one of many in a network. Okay. So a device can participate in multiple NAN clusters at the same time if it happens to be in an overlapping area where RF communications can take place. So it can be in multiple NAN clusters at the same time, and those NAN clusters may be part of the NAN network. So think of the NAN network like the ESS in 802.11 and the NAN cluster like the BSS. So this is a way that you can conceptualize it if you're already familiar with Wi-Fi to kind of wrap your mind around the difference between these two. Now let's talk about the features, then we'll get into the technical architecture. So the three major features of Wi-Fi Aware supported by NAN technical specifications are discovery, ranging, and data exchange. So discovery means that applications can discover other applications. So if you're thinking at the application level, such as an iPhone app, an Android app, then you've got this application that can talk with Wi-Fi Aware to other applications. And it allows that application to discover those other applications using the NAN engine. There are unique IDs used by the applications so that it is identified as a unique app and therefore can communicate with other instances of itself. It also implements a wake and sleep schedule among the devices in this process. So therefore, not all the devices have to be awake at the same time. More importantly, the devices have a scheduled sleeping algorithm which extends battery life. So rather than just being awake and talking all the time, they wake up, can communicate or receive communications, and then they sleep. And this is defined within the cluster. So within a cluster, there's a wake-sleep schedule that's defined among them and coordinated among the different device roles in that cluster. There's ranging. Now, this uses the 802.11 defined fine timing measurement, or FTM. So it simply uses what's already defined in the standard to determine range. And the accuracy of this range can be fairly good within a few feet. And so it is something that can be used for a lot of different things. For example, you can use it to say that only when the application detects it is within a particular range will it work, or you can say once it gets out of a particular range, it stops working, or maybe there's an alert because it's geofencing or something like that. And then, of course, there's data exchange, peer-to-peer data delivery with both unicast and multicast support. And you can have multiple connections for different applications. So the NAN engine allows for multiple apps to use the API and communicate through the NAN engine. It does use the 802.11 PHY, but remember, it's a modified 802.11 MAC because there are frames and frame formats used in a Wi-Fi aware cluster that really aren't used in a BSS or even an IBSS. So traditional 802.11, they're not used there. These are then unique to this kind of a network that implements the NAN engine. So let's talk about this technical architecture. Again, it starts at the bottom with the 802.11 PHYs, 11N or 11AC, and it's using the Neighbor Awareness Networking Engine, or the NAN engine. And the NAN engine is comprised of these three layers that you see in the middle with all of them on the green background. So we have the NAN MAC, which is the modified 802.11 MAC. In other words, it has some similarities to the 802.11 frames, but it's going to have modified frames as well. And these are the frames that are specific to the NAN engine. There's also the NAN scheduler, which is the thing that determines when communications occur, what the wake and sleep times are, and so forth. There's the NAN discovery engine, which is the specific portion of the NAN engine that allows for the location of a NAN cluster and applications in that cluster. Using beaconing, it can find out what applications are in the cluster to determine if it wants to connect or not. There's ranging, again, with FTM, and then there's the NAN data engine for actually transmitting data. So within the NAN engine are really three other components, if you will, that make all of the activities happen: the discovery engine, the ranging, and the data engine. And these are the three primary components that the applications are working with through the NAN APIs. So you can have multiple applications taking advantage of what is the range right now. This is data that I have to send, and I want to discover services that are available, and there can be rediscovery windows where you're discovering new services that might be available in the cluster that were not there before. So for example, your device may join a cluster because of application A, and it also has application B. But at the time of joining the cluster, there was no instance of application B in the cluster. However, it's very possible that another device joins the same cluster and has that application. And so rediscovery is important to discover that that application is now present, and it can also be utilized within the NAN cluster. So these are the parts and pieces, the different components of the NAN technical architecture that actually make it work. Remember, the standard APIs are used by applications. The benefit of this then is, if you think about it, the applications get to take advantage of location of networks and services, sending of data, and determining range without having to do any of that code themselves. They don't have to, for example, look at the Wi-Fi signal and try to figure out what the range might be from that on their own. They don't have to worry about how to determine with their own proprietary protocols what applications might be available within the cluster. All of that's taken care of for them by the NAN engine. So Wi-Fi Aware simply makes that available. Application developers simply need to take advantage of the API. Now, of course, they can only take advantage of the API if it's available on the device. So you're going to need a device that either through firmware or hardware upgrades supports Wi-Fi Aware and the NAN engine, or you're going to have to purchase a device that supports this, right? So this is something that if it catches on and begins to gain in popularity, is going to be something that happens over time. It's not going to be available tomorrow with all of your devices. It's going to be available at a point in time when your device is now supported. But this is true with any new technical specification. You know, WPA 3 just came out earlier this year, a month or so ago, and it's going to take some time before we see support for that in our access points and in our client devices and so forth. So the reality is that anything new takes time. We've had 802.11ac available to us for a few years, and yet we still see many networks where the majority of devices are 11n and they're not 11ac. So it can take a while for it to come along, but we'll get to take advantage of it more and more as it gains popularity. Now let's talk a little bit more about this discovery process that takes place. The first thing is cluster or device discovery. Now, we say cluster or device discovery because there may not be a cluster yet. It may be one device that is finding another device and they're forming the cluster for the first time. So it's going to either discover a device or an existing cluster, and it discovers these Wi-Fi aware devices based on range and using beacons. So there's beacons that provide information to any device that's attempting to discover a cluster that will tell it what's in that cluster, and based on the signal information, it can determine the range of that cluster and therefore whether or not it wants to connect or become synchronized. Now, once it finds a device or a cluster, it then goes through the synchronization process. It joins the group or pair, if it's just the two that become the cluster, of Wi-Fi aware devices, and it synchronizes message timing. So there's a master device in the cluster that manages the timing for messages. Time frames and channels are specified to reduce power consumption. So there's some interesting channelization that goes on with NAN, and I'll get into that a little bit later, but there's a channel that you use for discovery and synchronization and service discovery, and then there's a channel you use for data transmission, and they may very well be different channels. So we'll get into that momentarily. Once I'm synchronized, I'm part of the cluster. Now I can discover all the services that are in that cluster. And you'll notice that in the image to the right, that we have the light bulb only on 3 of the devices in the cluster. And that's because the device that on the far left was just trying to find a cluster, and then it synchronized with the cluster, and now it's doing service discovery. It has only found the service on those other 2 nodes in the cluster. And so it doesn't have to be that a particular service you're after is running on every single device that's participating in the cluster, but you can communicate with the ones in range that are in the cluster. And we use publish and subscribe messages at the application level to exchange this information. You subscribe, and that means you're searching, or you announce, and that means you're publishing. So if someone subscribes, meaning they're sending out a message that is a search message, I'm looking for this service, then the nodes in the cluster that have it are going to announce, they're going to publish, they're going to respond and indicate that they're running that particular service. So let me give you an example to think about how this might work. The example that's given by the Wi-Fi Alliance is frequently throughout the documentation is people at a concert. They also have it in their promotional video on their YouTube channel. And so the concept is there are multiple people at a concert. They're using a Wi-Fi aware device. They all end up building a cluster, and they've all got this photo sharing application. So everybody that takes photos at the concert, if they choose to, can have those photos shared with all of the other Wi-Fi aware devices. So if someone gets a great shot of the band on stage, then that shot's available now to everybody, but everybody else's shots of the band is also available. So that's an example. And this subscribing and publishing process is used for the different devices to coordinate. So it may be that in a concert with 1,000 people, there are only 7 people that actually have this application on their phone. But if they're all in range of each other, they may be able to form a cluster, and then they can all share their photos with each other. Note that a synchronization cluster is a collection of devices with the same defined discovery window. So there's a window of time where it's acceptable to do service discovery. You don't just do it all the time, anytime you want. That's what synchronization does. It defines the discovery window. The anchor master keeps time, and the role alternates among devices. So this timing that is there in the synchronization is managed by the anchor master. But the same device doesn't have to be the anchor master forever. This role can alternate or move among devices. Let's talk a little bit about these device roles. So I mentioned the anchor master that sets the timing. We see the anchor master represented in the burgundy color in this image. If you have a difficulty seeing that color, look at the top 3 mobile devices in the image. It's the one in the middle. And that one is the anchor master. There's only one anchor master in the cluster. Okay. Now note that not all of these devices in the cluster can communicate with all of these devices in the cluster directly, but we do have the ability to communicate with the devices sufficiently such that we can participate in the cluster through some chain of synchronization. Now the master transmits discovery and sync beacons. And notice that we have multiple masters in this case. Then the sync propagates timing to other masters. So the anchor master sets the timing, the sync propagates the timing to other masters, and then you have the multiple masters. So these multiple masters are what make it so that you may not be able to communicate directly with the anchor master, but you can still communicate in the cluster. And then your non-sync devices are just the ones participating in the cluster that are not actually playing any of these roles, the anchor master, the master, or the sync. They're just playing the role basically of a client, if you will, within the Wi-Fi aware cluster. Now I want to talk specifically about some NAN requirements before we get into some use cases here. First of all, 802.11n certification for 2.4 gigahertz is mandatory. So the only thing that's mandatory from a PHY perspective is a 2.4 gigahertz PHY. Yes, if you know me, you know this causes me pain. I wish they would have made 5 gigahertz mandatory as well, since it's a brand new thing going forward. I understand the potential is there because we're changing things in software, right? So the potential is there to use an older device that already exists, just update it through firmware to support Wi-Fi aware. And if it's a 2.4 gigahertz only device, it can still function. So I do get that concept, but at the same time, it sure would have been nice to have this push more 5 gigahertz adoption forward, making it so that at least new hardware is going to require 5 gigahertz. But it is what it is, and we have 2.4 gigahertz mandatory. 5 gigahertz 11N or 11AC is optional. So effectively what this means is if you're going to run NAN and become Wi-Fi aware certified, the device at the same time has to be Wi-Fi 11N certified for 2.4 gigahertz and optionally 5 gigahertz and optionally AC certified for 5 gigahertz. In other words, it's going to be a standard 802.11 device. that is Wi-Fi Alliance certified for 11N or 11AC. And in addition, it can be Wi-Fi aware certified in order to work with NAN. Now, an interesting thing is the channelization. So when it comes to discovery, the only place where NAN works is on channel 6. So it'll be interesting to see how this impacts things. If devices are brought into a large environment, let's talk about a stadium with 80,000 people, and we get to the point where 10% of them are Wi-Fi aware. That's 8,000 devices in the stadium that are all going to be doing discovery on channel 6. So you're going to see more saturation on channel 6 because of that. Now, these are tiny messages. They don't take up a lot of time, but the reality is it's an increase in saturation on that channel. In 2.4 gigahertz, that's just the channel that's used worldwide. Channel 6 is used for discovery. It varies in 5 gigahertz. If you're in a regulatory domain where only lower bands are allowed, then channel 44 is always used. If you're in a regulatory domain where only upper bands are allowed, then channel 149 is always used. But when both bands are allowed, take the United States, for example, where we can use the upper and lower bands, then channel 149 is used. So you're either going to be using channel 44 or channel 149 for discovery in 5 gigahertz. Now, it's easier for us to work around that, but it is important to know when you're designing Wi-Fi going forward, if we start to see a lot of these Wi-Fi aware devices out there, it's probably going to become important to avoid channel 44 or 149 in your design when you can for your Wi-Fi infrastructure, or to use it creatively and make sure you've always got another channel there that will not be as saturated. So that's something we'll have to just watch for. We really just don't know yet what the impact of Wi-Fi aware is going to be in this area. It seems, by looking at the specification, to be minimal, because when you look at what it actually does, it's not much worse than running, say, 2 or 3 SSIDs on an access point, in all honesty. So it'll be interesting to see the real world impact, but there you have that for now. Now, data transfer can occur on any other allowed channel. So just because I'm doing discovery on only channel 6 or 44 or 149, that doesn't mean I'm not using that, or that I have to use that channel for data transfer. I could, but I could also be using a different channel. So that can occur on any other transfer or channel allowed. And what that means is, of course, the regulatory environment allows whatever that other channel is. Okay, so let's wrap things up with this overview of what Wi-Fi aware and NAN is all about with some use cases. The first one is conventions, concerts, and other large-scale events that I've talked about already. So you can imagine being able to share photos, or that when you walk into the convention center, one of the many clusters that may be pre-established detects you and gives you, for example, access to maps for the convention or schedules of presentations and so forth. So you can imagine the potential use cases there. Museums, shows, other tours. So imagine you're going to a nice wildlife aviary or something like that, and you want to walk through it. And as you're looking at the different displays, you want more information. Well, your device can be detected to have come within 5 feet or 6 feet or 10 feet of a station. And at that station now, automatically a video's available to you, textual information, what have you, shows up automatically through the app that the museum or the show makes available. Obviously, it can be used for business data transfer. So imagine, for example, that you have an app that's custom developed on all of your salespeople's phones. And when they walk into their home, because you give them a device there, or when they walk into the corporate offices, their device automatically joins a cluster, downloads the most recent pricing information and inventory information, and uploads any sales data. That could be a pretty cool use case of something like this, even if they've never joined the Wi-Fi network before. Just because they have the app on their mobile phone that's been issued to them, it does this for you. So that's a option there, right? I'm brainstorming, thinking of different ways this could be used. Some potential use cases: person identification and authentication methods. So you could have an app on your phone that identifies who you are, and when you walk up to a particular area of the facility, you're able to access it because you've got that app on your phone, for example. Of course, we have other methods for that, but it's one thing. Range tracking in a manufacturing process. So imagine an automobile manufacturer, and they simply place a device in the automobiles that's going down the assembly line. And as it moves down the assembly line, it's automatically tracking it and determining where it's at in the process. And you could get all kinds of manufacturing flow analytics from this or anything like that you might want. Yes, we have other methods to do that now with RFID and other solutions, but it's yet another possible use case here. Geofencing for alerts. So you could have a device that is Wi-Fi aware on your shipping containers or on your forklifts. And if they go outside of a certain range where they're not supposed to be at the facility, then you could get an alert letting you know that that has happened. Or some expensive tool or device could have this on it to keep it within the geofence. Now, geofencing here, it's not really, GPS based with a map and so forth, but it's possible that it could tie in. So you could use both the fact that you're using Wi-Fi aware at the local facility, and the app is also taking advantage of GPS, and it's indicating, okay, currently based on my GPS, I'm at this location. That's what the GPS told me. And then my geofencing with Wi-Fi aware tells me that I'm within 60 feet of a certain area that I'm supposed to be. So this kind of thing could be accomplished as well. So you can imagine some of the potential use cases here. So this is Wi-Fi aware and NAN.